welcome back to the YouTube channel The Engineering Surveyor. Today we are going to show you how to orient a total station. First of all, we need to switch on the total station. So we have already set up the total station over a control point. This is 9010. The code of the control point is now 9010. We have the coordinates of the control point with us. So now I switch on the total station. So soon after I switch on, we need to check whether the tilt is okay. For that, we need to press shift and this tilt button. So shift and tilt button. So then you will get this digital bubble. So now accordingly it is a little bit out, so we need to bring it back to the center. So I go to digit option. From the digit option we can see the amount that we need to bring the bubble, right? So now 43 seconds out is there in the Y direction. So I will bring it less than 10 seconds. And this direction also, right, now almost level, right? 1 second and 2 seconds in X and Y directions. Now I will go back to the graph. Now according to the graph, the digital bubble is exactly at the center. Now I escape. First of all, before we start any kind of operation, we need to open a job, right? So now in your Word or Excel or whatever the application, soon after you open a Word document, the first thing is you save the document, right? In any case of the power cut or something, right, your file may not be saved, right? Therefore, first of all, we save the document. So similarly here we also need to create a file inside the total station memory, and we are working in that particular job, right? For that, here we have to press escape. This is kind of a different instrument from Topcon and Sokia brands. So therefore here we have a different option to go to the memory, right? But in other versions, other brands, there are different buttons we have to press for that. Now here we have to press escape and go to memory. You can see several options are there: configuration, memory, measure, like that. So here we go to memory. So to go to memory, we need to press F3. The button just below this MEM is F3. Go to memory. There we can see a job, known data, code, defined roles, right? Lot of options are there. So we need to go to job. So job selection, coordinate read job, job export, coordinate import, command outputs, right? So here job selection. Now first we need to create a job. So first go to job selection. There is an already created job, so I don't need to continue that job. Today I am going to create a new job. Therefore I can type a name, right? So now let's say today is the job 1. I can give it as job 1. So I'm going to change the name here. For that, first we need to change this digits to the letters. For that we can use this shift button, right? When we press the shift button, you see the letters appear, and whatever the number, I need to delete it. So for that I can use backspace, right? Backspace. Using backspace BS, I can delete the delete whatever in the display. Now I can enter the job here, JOB, and job 1. Before I press 1, I need to again change the letters to digits. For that I again use shift button. So job 1, right, click OK. Then go to coordinate read job. So when you have created a job, the coordinate read job should be the same if you are using the same location. You have, let's say that you haven't done any survey before in this particular location. So this is the first time you are going to do the survey. Therefore you can give the same name here for the coordinate read job. So here again I'm going to edit it, job 1. Right, it's okay. Now you have created a job and you have entered the coordinate read job as well. So next thing is, now your interface is working in this particular job, right? Before you start or before you do any orientation, next thing is you need to go to the EDM and change the electromagnetic distance measurement settings. For that there are options in this function button, right? So if you click this function button, you will see these things are changing, right? These options are changing: HD, SHV, HZ, EDM, like that. So I need EDM. So EDM, if I press F4, I can go to EDM settings. So we need to feed the temperature. So it is approximately about 30 degrees here. So I can feed that 30 degrees. The pressure in hectopascal. So this pressure usually changes with the altitude, right? So for that we can use a phone. Now here the altitude is about 10 meters from the mean sea level, right? Therefore we don't need to do any changes here, because this 1013 is the pressure which comes for the mean sea level, 0, right? So we are now at 10 meters here, therefore we don't need to change the pressure here. So accordingly this temperature and pressure, this ppm will change automatically. So therefore I am not going to change the ppm. Ppm is the part of the amount of water vapor in the atmosphere. And this PC is called the prism constant. Now here the prism constant is 0. So what is a prism constant? Before we teach you the prism constant, I will show you prism. This is called a prism, right? It is kind of a equipment where we can reflect the emitted signal back to the receiver. So this is the emitter and this is the reflector, and it reflects the signal back to the instrument, and the total station will receive this signal and detect the signal and do self calculations about the distance and all these things, right? So here the prism constant is shown here. It is minus 30. The meaning is whatever the effective center of this rays, somewhere 30 millimeters behind this pole axis. The pole axis is the exact point where we keep the prism, right? So it is just 30 millimeters behind this pole axis. Therefore that's why we feed it as minus 30. So whatever the reading we are getting, we need to deduct this minus 30 from the reading, right? Otherwise we will getting a wrong distance, right? So we need to feed this minus 30. So now here the prism constant you don't need to change, right? So if you come and see here, it is 0, but there is an option to select the reflector. Because it is non-prism, they have mentioned this prism constant has changed to 0, right? But when we select the option prism here, so now here non-prism, sheet, prism, like that options are there, right? Non-prism means you are not using a prism, right? Just the laser point, and the instrument will take the distance to the point. But the problem in the non-prism is it will reflect back from any obstacle it has when the rays passing through, right? So but if you are using prism, the instrument will detect only the rays coming from the prism, right? So now I have changed it to the prism. When I change it to the prism, you see the prism constant automatically changes to 30, minus 30, right? So then after the prism constant there is a mode, right? Fine R, right? R means whatever the signal you are sending is repeating continuously until you stop the signal, right? So fine R means fine repeat. And then tracking is again taking the continuous readings, especially in the moving objects. Let's say now this instrument is fixed in a harbor, and you can measure the distance from a ship to the jetty, right? So in that case, you can use this tracking mode, right? Continuously you are getting the readings of a moving object, right? So the tracking mode. And then fineness means you are getting only one signal, right? Single, fine single. S means single. You are getting just one reading from the reflector, right? And that's all, right? Then fine average. Now you see the fine average is you are emitting 3 signals and getting 3 readings and get the average of these 3 readings. So fine average will give you a kind of a accurate reading compared to the fine R and fineness, right? So fine average is one of the best option here. So here this number of signals you can change, right? There's an option to change the number of signals. Now you can change the settings such a way that it takes 9 readings and get the average, right? Then the prism, the reflector prism, and the temperature. All these are the EDM settings, or electromagnetic distance measurement settings in the instrument. So once you have done these settings, now it's time to orient the instrument. Right, now we'll see simply what an orientation is, right? So usually the orientation is just giving 2 details to define all the other parameters with respect to those 2 data. So as an example, I will show you an kind of example. Now let's say I have closed my eyes, right? I have closed my eyes. Let's say I am the total station, right? I am the total station. I have closed my eyes. Now I was given the place where I am, right? So now I am at the middle of this the ground, and now let's say I am looking at the north. So I know that the north somebody has turned me like this, and he says that I am looking at the north, right? Now even though I have closed my eyes, since I know the position and I know the direction where the north is, I can show the other places. Now I know the civil division is somewhere here. Whatever the division or the canteen is somewhere there, and the person who's recording me is somewhere there, right? So I can show the direction, because now in my mind I already imagine everything around me based on the location and the direction I am heading, right? So even though I have closed my eyes, right, so I can determine where I am and where I am looking, the direction I am looking, and where the other places, other details are. Let's say now the entrance is somewhere there, the road continues this way and the entrance is this direction. Even though I have closed my eyes, I can imagine everything. Similarly, for the total station, also we can feed its location and the direction. That is one method of doing the orientation, right? So that is called the Backsight Azimuth. There are 3 methods of doing the orientation. The first thing is Backsight Azimuth. The second one is the Backsight NEZ. So we are giving 2 coordinates to the instrument. So that is called Backsight NEZ. Right. So first I will show you what Backsight Azimuth is. Right. Backsight Azimuth is we are giving the place where it is. We are giving the coordinate of this particular point where the instrument has occupied, right, and the direction where it is looking, right. So now come and we'll see how we are doing the orientation of Backsight Azimuth. So now the instrument is in the face left operation. So first I need to go to the coordinate option, right. So now I'm going to work with the coordinates, right. So for that I need to press the function button until I see the coordinate option. Now when I press the function button, you see the options are changing, right. So now here I can see the coordinate option here. So I press F2, right. Then in F2 we have 3 options: observation, station data, backside data, like that. So I'm going to station. Going to station because I need to feed the data of this particular station, right. So in any of total stations you need to do this first, right, the orientation. Without orienting the instrument you can't work out, right. So now here already you can see some coordinates in the display. So this is the coordinate which was used for the previous activity, right? So therefore now we need to update the exact coordinates of this particular location. So now this is 9010, right? So I know the coordinates of 9010. It has the northing coordinate of 478,874.840. So now I'm going to update as per the coordinate sheet I get from the office, right? So now northing coordinate I'm going to update it this particular point. So 9010 478 847 840, and the easting coordinate is also there. Before we press this buttons, first we need to clamp it. I forgot to tell you the clamp. This is the clamping screw, you know, the clamping screw. So I clamp it and then press, then it will not move when we are pressing. Right now easting coordinate, so I need to give the easting coordinate. It is 413 77 3.907, and the height is also given here. For the orientation, actually you don't need the height, but the Z coordinate also there, so therefore I'm going to feed it 21 point. It is 21 meters high from the mean sea level, 0.35, and the instrument height. The next thing is we need to feed the height of this instrument, right? So we can take a tape and we need to keep it just above this control point, right? Not by the side of the control points. I have seen some people, they are keeping it on the ground, not over the control point. That is wrong, right? So whatever the height is given for the control point. Right, so I am taking the height to this point. So there is a kind of a mark in the total station, so I have to measure the height up to that mark. So accordingly it is 1.52. 1.52 is the height from the top of the control point to this point. So usually you see that this line is not vertical, right? This line is not vertical. That is one of the disadvantages we have in the total station, right? So that's why we are not taking the total station for the vertical control, right? But anyway, these readings have somewhat accuracy. But for precise surveying, we are using the level instrument for the vertical control, right? So anyway, now we can feed this height as 1.52. So this is the point where we should measure the height from the control point, right? So 1.52. So I'm going to feed the instrument height as 1.520. Then they ask the target height. So now since we are going to use the Backsight Azimuth option, I'm not going to use any target height. So I give just 0. Right, and I can record this if I want, right? So let's say I can record this point. So I can give the name. So I give it as 1. The point number is 1. And if you go back, the code you have to give as 9010. Right. The name of the person who has obtained or the name, let's say control point, you can give it as a control point. So go to shift and backspace, CP, control point. Okay, now we can record it. So we have recorded the point as number 1, and then we have to click OK. Then station data is okay. Then they ask the Backsight data. Backsight data is the reference data. Now I said I need the details of this particular point and another point or the direction, right? The direction where the should be headed. Now instrument is looking at a particular direction. So let's say now I have turned the instrument to the north, right? So let's say I have fixed a pole somewhere in a place where the exact north is, right? So now I have targeted to that exact point. Let's imagine, right? So I haven't exactly targeted to the north, but approximately I have targeted to the north. Let's say now I have fixed a pole somewhere there where the exact north point is from this point. So now I have focused to that one, right? So now I say that the instrument is in the direction of north, right? So now I need to feed that. So for that I need to go to Backsight data. So go to Backsight data. They ask the angle or the coordinate, right? So I go to angle, right? I need to give the angle where I'm looking for, right? So I go to angle. So HAR, right? That means the angle from the north, right? Set the azimuth. They are set the azimuth. Now I'm exactly looking north, therefore I can give as 0. So there already the 0 is there, but I give a 0. Then they ask the 0 is okay. Yes, I press yes. Now I have oriented the instrument. Now I can take observations with refer to these two data. What are the data? The station data, the north, east and z coordinate, and the direction where the instrument is directed, right? So that is called the orientation of instrument using Backsight Azimuth option. In our next video, we'll see how to orient the instrument using Backsight NEZ option. Thank you very much for watching this video. Don't forget to subscribe this channel and click the bell button for more of the very latest videos.